Hello and welcome. Now we are going to do a deep dive into the process control of the groundwater works. For those who hasn't yet heard the introduction to this video, I will post a link in the description field below so you can go back and have a good introduction before you watch this video, or you can go ahead and watch this video. Right now, I will hand over to Kjetil Sørhus at Sørhus Program Development, who has done the programming together with me for the process. So, enjoy the video now.
Thank you, Magnus. My name is Lars Kjetil Sørhus, and I run Sørhus Programutvikling in Kristiansand in Norway. I have a degree in process chemistry, and I work with automation and instrumented safety systems, specializing in Siemens PLC equipment. And today I will go through the control system for the Stonga groundwater works and show which main components should be in place on such a control system. I will start going through the HMI, that is the display system for the control system, and then go through the PLC program to show how it is set up in terms of process control and safety functions. And the main areas I want to focus on are controls, that is how the operator is handling the system, the alarms that should be shown in the system, the trends for the values of the system, the logging, and finally troubleshooting. That is how we can help the operator to remedy any problems that should arise during operations. So I think we'll jump straight to the HMI and start display how the system is shown to the operator. Okay, here we see the main screen for the control system. Here we have the information about the hydrofor, which provides the water for the households, with the outlet here. We have the drill hole to the right, and we have the well to the left. In the middle, we have the UV filter, which cleans the water before it enters the hydrofor. On this hydrofor, we have different set points. The green shows the maximum pressure under normal operations, and the blue one shows the low limit pressure under normal operations. So what happens now, when the consumers are drawing water, the pressure will drop in the hydrofor. And when it reaches 2 bars, it will start the automatic pumping sequence. And to make sure that the quality of the water is as desired, Magnus has calculated that if we draw 10 liters from the drill hole and the rest from the well, the mixing will give an adequate quality of the drinking water. When it's in auto, it will automatically start with the drill hole, and as the settings are right now, it says pull 10 liters from the drill hole. When it's a pump 10 liters, it will continue to pump from the well until we reach 4 bars, and then both pumps will stop. The UV filter will start automatically when the pumping sequence starts. And we can see here on the top left corner, we have a status window showing what the system is doing right now. So now the hydrofor filling is finished. So we have water, and we are waiting for the level to drop to 2 bars so the pumping can start. We also have different values showing here. These are 3 different temperature sensors. We have the pressure in the hydrofor. We have the conductivity of the water inlet and outlet of the hydrofor, and we have the levels in the drill hole and in the well. Now we can see this button says auto, which means we have full auto system. It starts both pumps automatically. And now when it reaches 2 bars, it starts by starting the UV filter. When the UV filter is ready, it will start pump 2. And it will pump 10 liters from the pump 2. When 10 liters is reached, it stops the pump and it starts pump 1 to draw water from the well. And this will continue pumping until we have reached 4 bars in the hydrophore. So this is the normal operation of the system in full auto. We can also see these green bars on the sides showing that the system is running in full auto and we have no errors. But 4 bars, the pump stops, it says hydrophore filling finished. So now it's in standby and waiting for the pressure to drop to 2 bars again. Now this is normal operation full auto. The operator also has the option to select only running one of the pumps. So say we have a problem with the drill hole. We can say we only want to draw water from the well. Then we can put it in auto pump 1. This shows we have a yellow status, which means it's semi-automatic or it's partially running. And now it's partially running because the pump 2 is shut out of the system and it will only run pump 1. So when the level reaches 2 bars, it will start the UV filter and then start only pump 1 to fill up to 4 bars. The same way we can start only pump 2. If we have it in manual, no pumps will start automatically and have to start them manually. To start them manually, we have these start pump 1, stop pump 1 from the well, and we have start pump 2 and stop pump 2 from the drill hole. So if we start pumping from the well, it will continue automatically until it has reached 4 bars or until we stop it manually. Now we're pumping and it is increasing, and we can stop the pumping here. Likewise, we can start from the drill hole, start pumping drill hole, and if I don't stop it manually, it will stop automatically at 4 bars, which is the limit. But now we will set it to auto to make sure that we have normal operation again. So next time it reaches 2 bars, it will start from pump 2 and then from pump 1. We also have on this screen the information of the project. The status window up here says simulation is activated, and we can also select Swedish or English just by clicking on the flag. But since it's the English presentation, I think we'd better run with English. This is the main screen and the main operation of this screen. So I think we'll continue with the next now, which is parameters. To go to the parameter screen, we'll press the button F10. Here we can access all the parameters and all the process limits and alarm limits for the system. Now the values shown in white are read-only. So these are values that are only shown, but the values in blue or cyan can be changed by the operator. Here we have process limits, high and low. This says something about how the system should work and what levels it should start or stop. And the alarm limits show when the alarm should be set. So for instance, we have the hydrophore. Normal maximum limit, high limit is 4 bars and normal low limit 2 bar. This means that when the pressure drops to 2 bars, it will start pumping. It will stop pumping at 4 bars. The alarm limits, high and low. This is if the pressure exceeds 4.5 bars, we will get an alarm. Or if it drops below 1 bar, we will get a low limit alarm. So the difference is process limits determine how the system should run, and alarm limits are alarms that are activated if we are outside of the allowed parameter limits. We have 3 more parameters down here, which is 2 for the UV filter. As we saw on the main screen, before we start pumping, the UV filter starts automatically. And the reason for this is that it needs a certain time to start up to get warm before it starts working. So if we start a pump, I can show here, you start the pump manually, it will automatically start the UV filter. It will blink while it's warming, and when it's finished, the pumping will start. Now this is only 5 seconds here because the simulation, normal operations take quite a lot longer, but this is a parameter we can set here. How long it should start before you start pumping. In addition, these UV filters have a limited lifespan. So we want to limit the number of starts and stops of the UV lamp. So therefore, when it is started, when the pumping has stopped, we wanted to wait for a certain number of seconds before it shuts down, in case it's between pump switching. So when one pump stops and the next one starts, we do not want the UV filter to shut down and then start again. So we have a wait time before auto off, which is here set to 30 seconds. And this means if no pumps are running within 30 seconds, it will shut down. And when we are starting the pumps, we will wait for 5 seconds after the UV filter has been started until we actually start the pump, so the UV filter has a chance to get warm. The final parameter is the pump volume before pump switch in liters for pump 2. As I said, we want to have a certain amount of water from the drill hole before we switch to the well. This is in order to mix the water quality, so we have an adequate water quality in the hydrophore. And Magnus has calculated that for this system, 10 liters from the drill hole and the rest from the pump hole, from the well, is a sufficient combination. Now, to change a parameter is quite straightforward. Let's say we want to increase the process limit for the hydrophore. We simply click in the area, 4.2 bars, and enter. So now the new value is 4.2 bars. So this is the way to change the process limits and the alarm limits, and also the set points for the UV filter and the pump O2 volume. Now, the next I want to show you is the trend windows on this system. This Siemens comfort panel has a built-in trend system. So if we push button F11, we open the trend window. So here we have 4 of the values. We have the level in the well, level in the drill hole, the pressure of the hydrophore, and also the flow meter. Here we have some standard controls. We can zoom in and zoom out to see more or less of the values. We can also move this slider to get the value at a certain time. So we can read the values right here at this moment in time. The time spent is quite limited on these, so it's not meant as a trend system for long-term monitoring. But it's a very easy way to see that the system is operating in a normal way. We have 2 trend windows, as each window only can show 4 parameters. So we have 4 on this one, and the conductivities and the temperatures in the next windows, the same controls. Now, the next I want to show you is the accumulators. And we want to show accumulator for how much water is pumped and for how long time the pumps have been running and the UV filter has been running. So we have 2 accumulators for each unit. We have hours total and number of starts total. And we also have hours since reset and number of starts since reset. So as the text says, hours total is how many hours has pump 1 been running since the system was started. So here's 9.02 hours. It has had 6,119 starts. We can also reset these values. And here we can see the last time was reset was June 26th at 1:02 p.m. When we press the reset, all the reset values will be set to 0, and it will start accumulating again until the next time we reset. So we press reset, 24th of July, and we have 0 on these values. So When the pumps start and when the UV filter starts, it starts accumulating again. Number of starts and hours of operation. This can be good to have, in particular for maintenance. Typically, pumps and UV filters have certain service intervals that normally are per hours or number of starts. We have two pages with accumulators. This is for the pumps and the UV filter. And we also have the total water volumes for the well and the drill hole. In total, we have pumped 169,000 liters from the well and 2,000 liters from the drill hole. And nothing since we reset now 1 minute ago. Now, the next one I want to show you is the status for the pumps. We have a separate page for this showing pump 1 and pump 2. This is actually almost a copy of the command block on the PLC. On the left side, we have the inputs for the block. All these have to be green for the pump to start. And on the right-hand side, we have the output. We can see now, while we were watching, pump 2 was started because we have the start command, contactor is running, the emergency stop is okay, no interlock on pump 1 or UV filter. When pump 2 was finished, it switched to pump 1. So all inputs are green, then it starts, and we have start out and have a running signal. And it will now run until the hydrophore is full, and it will go back to waiting position. 4.05, which is here. It was stopped, and it's standby again. You can see now the interlock 2 is yellow, which means right now we can't start because the UV filter is not started. If I should go in and manually set the UV filter on, you see when it's warm, it's okay. And I can see here, all of these are green. So now the pump can start. If I shut it off again, I have an interlock which prevents the pump from starting. This is a very good way to check if the motor is running as intended. So if the pump doesn't start, we can always start to check here, are all the inputs or the prerequisites okay? So all these need to be green for the motor or the pump to be allowed to start. Now, if we can't find the problem for the pumps here, we can go to a screen showing the status of the PLC itself. Here we have the screen showing the digital inputs of the PLC, the digital outputs of the PLC, and also the analog inputs. These are raw values in Siemens values coming in, not the engineering units. So you can see right now we have one high input, emergency stop okay. We have one output, light tower green. Light tower green, this is an output that goes to a light tower outside the building. So you can see from external the status of the system. You see we have green, yellow, and red, which corresponds to the status shown on the sides here of the screen. If we are missing a signal, we can see, okay, do we have the low level signal from the well, for instance? Is it activated on PLC? You can check that here. And also, if the pump doesn't start, well, we can check here, is the start signal actually set? Now we can see we got the start signal for the UV filter. We are waiting for the UV filter to be warm, and now we have the start signal to the pump 2. We now know that it's going to pump 10 liters, and then it's going to switch to pump 1. Here we have pump 1 is starting. We have the input, the pump 1 running signal is okay, and the UV filter running is okay. Now when the hydrophore has reached 4 bars, it stops automatically, and it returns to the signal status we saw when we entered the screen. The pump stops and is again waiting for the next start. emergency stop OK, light tower green. We also have a function here where we can simulate or override inputs. Say we have this, if we set the problem with one of the signals, we have the option of overrunning this oversteering system. So we can actually say, okay, I want to force input signal, say from the status of the UV filter, we can force it high to make the system run normally again. So now we see when I click it, it turns yellow. It says I can now change the system manually. If I click this one, I override. Now the PLC thinks that the UV filter is actually running. But this is, as you see, a force signal and should only be used when troubleshooting. If I remove the forcing, it goes back to off, which is a normal operation. Finally, on this screen, we have we can set the date and time on the PLC. Typically, we have some time drifting on the PLC and the HMI. And if we want to make sure that the HMI and the PLC are running at the same time, we can simply click this button here, copy date and time from HMI to PLC. So when I click this one, it will copy, they will read the date on the HMI and write it to the system clock on the PLC. Like this, we can see they are the same. Okay, 1 second difference. It's a very easy way to make sure that the system time and the PLC time is the same, which can be important for troubleshooting, for instance, trends and loggings. Okay, the next one thing I want to show is the sequence overview. Now, as you remember, this system runs in a sequence that fills for 4 bars and then drains down 2 bars and then restarts the whole pumping system. And this is the screen that shows where in the sequence the PLC is running. Now, a note, these texts are currently only in Swedish. And this is because this is text that is being read from the PLC. It is not a text that is manipulated by changing the language up here. So this will be changed to English language when that is necessary. But this is the reason why it's only Swedish here now. So to the right here is shown all the steps in the system. To the left here shows which step it's waiting in. Now it says waiting for start. And these lights here shows the prerequisites that must be filled for the sequence to continue. You can see now it's 3.55 bars. It's just waiting for the pressure to drop to 2 bars. So this says here, it's not in manual and the emergency stop OK, it's green. Now it says either the Hydro 4 request water or manual starting of sequence. So when the Hydro 4 asks for water, the sequence will start. I can speed this up a bit so we don't have to wait until it's 2 bars. I can set this one to 11,000. Yes, now we see we are down at 2.35. As we know now, when this reaches 2, it will start the pump. So we go to the sequence window. It's waiting for start. Now, when this one turns green, it will be so quick we probably won't see it. There we are. It starts the UV filter in step 20. Step 30, starting the pump. Step 40, it's pumping. And now, either till we have reached the level or there is an error. Now we switch to pump 1, continues as we know from the well, till we have reached the limit or we want to abort the sequence. And now when this step is finished, it will end and go back up to step 10 to wait for a new start. So we'll wait and see what happens when it reaches 4 bars. There we are. 4 bars in the hydro 4, system is finished, and you're waiting for next start. This is a very good tool to troubleshoot. So if the sequence is hanging a step, we can always go in here and see, okay, which of these are not green. Right now, it either needs to be requesting water, or we need to have a manual start of the sequence. So we know if we don't put in manual, if it's not in auto, it won't start. So if I put this one manual, we see this one is not green. Okay, then the sequence will never start. As I said at the beginning, one very important part of the process control system is the alarm system. And on this system, we have 3 different alarm and information windows. We have the unacknowledged alarms. Unacknowledged alarms means alarms, new alarms that have not yet been acknowledged by the operator. We have the standing alarms or pending alarms. These are alarms that have been acknowledged by the operator but are still active. And finally, we have the system messages, which is information from the PLC and from the HMI to the user. I will trigger some alarms now just to show how it's shown here. And what we can do, we can go to the simulator window. Here we can simulate some faults. Let's see, I want to simulate emergency stop. Someone presses the emergency stop on the system. Press active, and we have a whole lot of things happening here. First of all, we see we have these red bars on the side, which says the system is stopped. We get a pop-up window showing emergency stop activated and the time and date for this incident. Close this one. We also have to top left here, emergency stop activated, and we'll have a pop-up window showing we have 1 pending alarm. If I open the alarm window now, so we can see here, emergency stop activated, okay. Sorry, the unacknowledged alarms, we can go to the pending alarms, which is the same alarm. Now, what happens when I acknowledge this alarm? You say, okay, I have seen it, it's okay, and remove it. Now we see we have no more unacked alarms in the alarm window. But if we go to the pending alarms, it's still here because it's still an active alarm, but the operator has seen it and he has acknowledged it. The main reason for having these 2 windows is if you have typically on bigger systems where we can have many alarms simultaneously, it can be, if you have only 1 alarm window, it can be very difficult for the operator to see when a new alarm comes in. If you have 30 alarms and you suddenly have 31, it's very difficult for the operator to see. So here we have the pending alarms that have been acknowledged, and this window shows new alarms. So if I play the devil's advocate now and I trigger another alarm, MUV1 alarm, this is the UV filter has a fault. Okay, new alarm, pop up. Now this is, we have 2 pending alarms. I go to the unacknowledged alarms. Okay, I have a new alarm. This one has not been acknowledged. MUV01, no disinfection. Acknowledge it. No more new alarms, but we have 2 pending alarms. Now the only way to get them remove them from here is to actually correct the error. And the way to do it now is to say no fault and okay. So now we have no more alarms in the system. But the system is still in manual, so we have to put it back in auto to make sure it is running normally. So we acknowledge the alarm, we correct the error, and then set the system back to auto. This is the way to do it. Yep. And that was the alarms on the system. Now we're getting close to the ending, and the next thing I want to show is the status of the system. As you remember, we have these green, red, or yellow bars on the side of the screen, and we can see what determines the system. Here we have three columns: status green, status yellow, and status red. So if we have, for instance, a yellow status, a green status, we know that it's not red and it's not yellow. Then it's okay. If any of these are activated, we get a yellow status. So say I put in an auto PO2. Now the yellow, you can see here, okay, it's yellow because we have activated the auto PO2. This is the reason for the yellow status. And we have a number of different situations that will activate the yellow status. And here we can see why. Likewise, for status red, should I put it in manual, it will be red because as now it's because manual is activated. And we have here the description of all the different statuses that will activate the status red. Earlier we tried to activate the emergency stop. You can see here, if emergency stop is activated, we will have the red status. Now we go back to auto and everything is green and well. This is also to help the operator troubleshoot in case there is a problem with the system. Now the final thing I want to show is the simulator. As I explained, all the values here are run on the simulation, and we can set these parameters on this screen. Now all these values are system values or status values on the PLC. These are not engineering units. When it says level 23,000, this is a Siemens value that goes from 0 to 27648, which is the maximum. So if I want to simulate a low level, say in the drill hole, you can see here now the drill hole has 22,000, which is quite a lot. You can put 1,000 or say 500, very small number. And then you see, oh, we actually have a low value here. So these are all parameters that we can use to manipulate the system when we're simulating. This is the level, and this is the change for these values during the simulation. Here we can also set the simulation on and off. So if I go off, it will use the actual physical inputs. But since this is a simulation on the PLC, we have no input, so it will just stop. Likewise, we can here simulate faults. Start fault on pump 1, pump 2. We can simulate a low level in the well and the alarm for the UV filter and also for the emergency stop. We can try now the low level in the well to see, okay, what will happen if the well went dry? We have a red status. We get the alarm, level 3, stop level in the well. You can see here on the F21, the status is red. And we have manual activated. And the reason it's manual because when you have a stop level or a status red, it's always set to manual to prevent the pump from starting. We have one active alarm, which you can see here, stop level. We can acknowledge it. It's still in the pending alarms. So this is the simulator screen for the system. Reset the value, and everything is okay again if you put it in auto. Yep, but now the final screen on these function buttons here is the system screen. It just shows some information on the project and on the author and description of the plant, and also has some default buttons for the comfort panel. It's like the language toggle, online, offline. You can stop the runtime on the screen. You can have some user administration, system information, and you can also go to the operating system on the screen. It's a bit more technical, but it's all available here. Now, the last thing I want to show is export of the logs, because these values are set up to be logged at certain intervals. Some values at the second level, some at 10-second level, and some at maybe 5 or 10 minutes. But to export these from the HMI, I have created a program that does it semi-automatically. If you press F1, it will open the window for export logs to computer. So the first thing we do is we have to stop the logging, push the button. It says here, information, all the logs have been stopped. Then we take export file. It says here, okay, we have ready to export. Now we remove the USB drive from the comfort panel. On the rear on this panel, there is a USB port, which has a USB thumb drive on it. Now these files have been exported to this USB drive. So it says now remove the USB drive, move the files to the computer, and reinsert the USB drive into the comfort panel again. When this has been done, you insert the USB drive back in the panel, then you can start logging. Logging has been started, and you want to reset the logs so they don't grow infinitely. So reset all the logs. You get a warning, this will reset all logs, confirm that all logs are retrieved, and reset all log, yes, reset. So now logs have been closed, and it's started logging in on fresh logs. These logs are exported in a CSV format, which can readily be opened in, for instance, Excel. This was the walkthrough of the operating system on the panel. I hope it has been informative and that you have received the information you need. Should you need additional information, please contact myself or Magnus, and we will be helpful to guide you. Thank you very much, and I give the word back to Magnus.
Well, thank you, Kjetil. Very interesting indeed, and soon we will have this system up running. So the cat just came in, so that's why I was the last second. No, thank you very much, Kjetil, and I think you're maybe also contemplating a video about the PLC that we will do when time permits, but how about that PLC video? What's your thought about that?
Sure. I can take a walkthrough of the PLC program, how it's been built up, and all the different components of the PLC program. That could be interesting. Sure.
No, I think there will be some listeners that will enjoy that. But again, we'll get back when we do that, and well, I'll say good night and goodbye from Gotland, and all the best to you and your family, Kjetil.
Thank you. All the best to you too.
Okay, take
Thank
care
you
now.
for listening.
Bye-bye.
Bye. Bye.